Last week we did a great job of putting a couple different things together, and these were them. First derivative test. What did we say about first derivative test? What is that going to do for me? Maxes and mins. Local maxes, local mins. Also going to give me information about intervals that are, so I heard critical, increasing and decreasing, of course, right? Okay. Second derivative, what's that going to do for me? Inflection points, concavity, right? And we talked about some scenarios where, some special scenarios, right? Where we have some weird concavity and things like that, okay? Or where we don't have inflection points, right? So we've looked at all of that information, right? Well, part of our question right now is, well, what are we going to do with that, okay? What are we going to do with that? And these two examples, guys, are going to be something that we can do. So what I'm going to do, guys, I'm going to give you a curve, okay? And I'm going to ask you questions based on that curve. But here's the problem. Look at how that curve's labeled. It's labeled as the what? As the derivative, right? Now, if you look at all these questions, what are all these questions referring to? F of x, right? So what we need to do is we need to answer questions about a curve that we can't see based on a picture of the derivative, okay? Now, fortunately, we have all these rules that we've sort of built up over the last week to handle this, right? So here's what I want to know. Where is f of x decreasing? Well, we know the rule. We know that f of x is decreasing when the derivative of f of x is what? Less than 0. Agreed? All right. Now, give me an answer of a value that is less than 0. Any number that is what? Negative. Any number that is negative, right? So if I look at this curve, and this is a curve of f prime, do you guys agree that anywhere it crosses the x-axis, it equals 0? And do you agree that anywhere below the x-axis, it's less than 0? And anywhere above the x-axis is greater than 0. So, where is it decreasing? Anywhere this function is negative. So this part and this part. That's where the derivative is less than 0, agreed? So what are those intervals? 0 to 1, 6 to 8. Again, can I see that behavior? Can I visualize that based on can I see the original curve? No, right? So I have to use this derivative to answer that question. Second part, where do I have local maxes or mins? Well, I can't determine anything about extrema unless I know where I'm decreasing and also where I'm increasing, right? So in order to answer this question, I also need to know where f of x is increasing. So where is this graph greater than 0? Well, all of that and all of that. So would you agree that the derivative is greater than 0 from 1 to 6 and from 8 to 9? All right, so I know where I'm increasing. So now I want to know, where do I have maxes or mins, right? And where do I have maxes or mins? When I change from a curve that is decreasing to increasing or increasing to decreasing, right? So I can say that f of x has a local min and f of x has a local max at blank, So we'll fill in the blanks in a minute. Because, and because. So how do I have a local min? Ready? Look at me. To have a local min, what do I need to do? Give me a word. Decrease and then increase, because the derivative changes from decreasing to increasing, because the derivative changes from increasing to decreasing. All right. So are there any points on this curve where I change from decreasing to increasing or increasing to decreasing? Right here. What was I doing before it? Decreasing. What was I doing after it? Increasing. So this must have been decreasing to increasing is a minimum. So I have a minimum at 1. Oh, I should actually say what? Oh, actually, I'm fine. Read the question. At what values of x? It didn't want to know at, it didn't say what are the minimums, right? So at x equals 1. All right, then I'm what? Increasing until I get to a critical value. What am I doing after it? Decreasing. So I'm increasing and then decreasing. So 6 was a maximum. And then I'm decreasing and then I'm increasing. So 8 must have been a minimum. Okay? And my explanations make sense? All right. On what interval am I concave up? F of x is concave up when what? Second derivative is positive. What's my issue? I don't have a picture of a what? Second derivative. I have a picture of a first derivative. Guys, can you draw a tangent line along this curve? So at my mouse, would the tangent line right here be positive or negative? Positive. How about here? Positive. How about here? Positive. So would you agree that anywhere along here, I have positive tangent lines? Guys, what are tangent lines to the first derivative representative of? Second derivatives, right? Yeah, those pluses right there are second derivatives, right? They're slopes of the first derivative. What's my slope at this point? 0. What is my slope between these 2 points? Everybody? Negative. And then it is 0. Oh, hang on. First it's 0, and then it's positive. And then it's 0. And then it's negative. And then it's 0. And then it's positive. So guess what? All of those green marks represent the second derivative. So where am I concave up? Anywhere that I have pluses. So where does that happen? From 0 to 2. And from 3 to 5. And from 7 to 9. And what does it ask for now? Now it asks for changes. Oh, I'm sorry, it asks for inflection values. But I can't find inflection values unless I know where I was not only concave up, but concave down. right? So where am I concave down? Well, it's when the second derivative is less than 0. So where are my negative signs? Well, from 2 to 3, from 5 to 7. 2 to 3, 5 to 7. Two to 3, 5 to 7. Got that. Okay, so those are where my what? This is where I'm concave down, right? So now here's what I need to know. I need to know inflection values. Where do I have inflection values? F of x has inflection values when the concavity changes from positive to negative or negative to positive. Does it matter which way? Concave up to concave down to concave up. They're both inflection values, right? Neither one's significant in terms of like mins and maxes, right? So let's look at this. Where are possible inflection values? Anywhere I have what numbers on here? Zeros, right? So let's talk. I went from concave up to concave down, so this must have been an inflection point. I went from concave down to concave up, so this must have been an inflection point. I went from concave up to concave down, inflection point. I went from concave down to concave up, inflection point. So concavity changed at all of those values, didn't they? So I have inflection points at 2, 3, 5, and 7. Say it one more time. I don't think I got it. Mm-hmm. Correct. Yeah, exactly. That's exactly right. Yeah. So if I'm up, so if I was reading this without a graph, I would just say, okay, from 0 to 2, I'm up. 2 to 3, I'm down. So 2 had to be an inflection point. So yeah, it's sort of like the repeating values in a sense. Yeah, you can think of it that way. Guys, this next piece right here is tough. Okay. It's tough to create a graph of what we can't see. But what we've done is we've gathered a whole bunch of facts, right? So what we're going to try to do is we're going to try to take all of this information to create a curve. Now, it happens that we have a limited domain, right? So I'm only going to go from 0 to 9. So on my curve, I'm just going to go up to 9. I know I went to 10. It just fit. I lied. I won't have my curve go all the way there, okay? Now there is only one fact here, guys. It says assume that f of 0 equals 0. All right, so sweet. We got a point right there. Now, there are only a couple of facts that have to be true on my graph. And this is where I start, okay? I know for certain that I have a minimum at 1 and 8. Sorry, wrong. I know for certain that I have a local minimum at 1 and 8 and a local maximum at 6. Agreed? Do I know if 1 or 8 is higher or lower than each other? Could they be at the same height? Could one be higher than the other? Yeah, they're local, right? I know that 6 will be an absolute minimum, right? How do I know it's going to be an absolute minimum? Because it's a closed interval, right? And this was the only value that was what? A minimum. So there's no value that's going to be lower than this one, right? So I know I'm going to have a high value at 1 and 8 and a low value and the lowest value at 6. So I'm going to go to my curve. A high value at 1 and 8 and the lowest value at 6. Now, again, if I wanted to, guys, I could have had 1 and 8 be sort of off-center from one another, right? Will I have any points that go higher than those two? Definitely not, because if I did, I would have had more maxes, right? Okay, now here's what I'm going to do. I'm going to literally go to my facts and read carefully about what I'm supposed to do. So, from 0 to 1, what am I supposed to do? From 0 to 1, I'm supposed to, what did I do? Oh, 1 is a minimum. Oh, did I write these backwards? Yeah. Oh, okay, sorry. 1 and 8 and 6. Thank you. Sorry. All right, there we go. 1 and 8 and 6. So go up to my facts. Fact number 1 says from 0 to 1, I'm supposed to what? Decrease. Is anybody surprised by that? If I have a point here and a point here. What kind of concavity should I have from 0 to 1? Concave up. So from 0 to 1, I'm simply going to draw a continuous curve, decreasing and concave up. Is that concave up? Yeah. Is it decreasing? Seem okay? All right. Now let's see what happens from 1 to 2. From 1 to 2, I'm still supposed to be concave up, right? However, I'm supposed to be increasing, right? So from 1 to 2, I'm concave up and I'm increasing. So I'm going to make a little note. 1 to 2, CC up and increasing. How about from 2 to 3? 2 to 3, I'm supposed to be what? Concave down. And what? Increasing. Okay, 2 to 3. Concave down and increasing. How about 3 to 4? 3 to 4, I'm supposed to be concave up and also to 5, right? So I'm supposed to be concave up from 3 to 5, and I'm supposed to be increasing. So 2 to 3, 3 to 5, concave up and increasing. How about from 5 to 6? Concave down. Still increasing though, right? Everybody agree with all those facts, right? So I'm literally just taking the facts that we derived and I'm making a list. So ready? Everybody agrees that from 1 to 6, the whole way, I was increasing. These are my changes in concavity, right? So watch what I'm going to do. I'm going to put a point here, 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 and here. Do you agree that all of those points I'm increasing? Now I'm just going to play the concavity game. 1 to 2, I'm concave up. Is that concave up? Yeah. 2 to 3, I'm concave down. Was that concave down? 3 to 4, concave up. 4 to 5, concave up. 5 to 6, concave down. So this last piece I'm going to be down, but all these other pieces I'm going to be what? Up. So I actually might have to move this 1 point a little bit. There we go. Right, I'm just matching all of the what? All of the facts to create a curve. And it's not an easy process, right? You got to really, it's kind of a tedious process to do. All right, how about 6 to 7, 7 to 8? So 6 to 7 puts me in concave down, 7 to 8, concave up. 6 to 7, concave down, 7 to 8, concave up. But the whole time I'm decreasing, right? So let's see here. Concave down to concave up. Concave down to concave up. There it is. That looks concave down to concave up. And then the last piece is on what? The last piece is I am concave up from 8 to 9. 8 to 9, concave up. So it's not the easiest process, but again, if you take it step by step, you find your points that they give you, which was 0, 0 in this case, right? You find your maxes and mins, and then you play the concavity game to connect the dots. Now, your curve could look different than mine, right? Because nobody said how high the highs are and how low the lows are, nor where this point is, but the concavity and all that will be the same. Cool? All right, so let's just get this going here, and then when we come back, we'll draw our curve, and then we will, you'll have some time to get started on some work, okay? Here's what I want you guys to do. In the next, actually, let's do this. Let's take the next 7 minutes. Why don't you guys see if you can answer A, B, C, and D? All right, don't do E. When you come back from break, I'll give you the solutions to this. We'll talk about them, and then we'll graph it. Okay? So take the next 6, 7 minutes and see if you can answer those questions. You guys did. So, again, you got to read the question. You got to make sure that you're answering what's being asked. You got to make sure that you're paying attention to the labels again. All right. So again, I give you a first derivative. Okay. Could I give you a regular picture of f of x? Boy, would that be easy then, though, right? Okay. If I actually gave you the picture, right? Okay. So. Increasing, we said we are increasing. Guys, I'm not going to write down the justifications again, okay? Same as before, all right? So just know that they need to be there, right? Where am I increasing? Derivative greater than 0, derivative equals 0, derivative less than 0, all right? So increasing anywhere, that part's true, correct? All right, so that's going to be anywhere I am positive. So here to here, here to here, here to here, okay? Again, on what open intervals? So we're going to go from 0 to 2. We're going to go from 4 to 6. We're going to go from 8 to 9. You guys check your paper out? Okay. You guys got that one perfect? Okay. Mikhail, watch your eyes, okay? They were both good. They were both good. Okay, now, this is not a question, but we know that we need this in order to answer the next part, right? So I am decreasing anywhere my derivative is less than 0. So fair to say that goes from 2 to 4. Fair to say that goes from 6 to 8. Pretty good with that. All right. Again, open intervals, right? All open intervals. So again, local maxes, local mins. Okay. And so again, I always like to do this. I actually visualize that when I'm answering these. Okay. To be in a maximum, what did I have to do? I had to increase. I had to go from an increase to a decrease. So I went from an increase to a decrease. So 2 is a max. From 2 to 4, I decreased From 4 to 6, I increased. So 4 is a min. From 6 to 8, I decreased. From 8 to 9, I increased. So 8 is a min. What did we say about 6? 4 to 6, I increase. 6 to 8, I decrease. So 6 had to be a what? Had to be a max. Now, am I going to include 6? Am I going to include 6? Well, let's hold on a minute. This is a graph of the derivative, right? When am I at a max or a min? I'm at a max or min when, first, I go from increasing to decreasing or decreasing to increasing. Second, the derivative is equal to what? 0 at that point, right? Or the derivative does not exist at that point. Agreed? Yeah, so does the derivative exist at 6? No. So is that a potential spot of maximum or minimum? What was I doing before I got there? Increasing. What was I doing afterwards? Decreasing. So I went from increasing to decreasing. The derivative didn't exist at that point, but that's okay because that is a critical value. Correct? So 6 is a maximum. Okay. Concave down. When am I concave down? Second derivative, less than 0. To get my second derivative, we play the plus minus 0 game. Tangents would be what? Negative, 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 0. Positive, 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 positive. Does not exist. Because in order for a what? In order for a derivative to occur, what has to happen? I got to be continuous at that point, right? And then what am I? Positive, 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 right? Those are all positive slopes. So I am concave down from 0 to 3. And that's it. I am concave up from 3 to 6. And from 6 to 9. Where do inflection points occur? Inflection points occur where I have changes in concavity. So what did I do here? I went from a concave down to a concave up, which means 3 had to be a inflection point. Would I have another inflection point at 6? Give me a better reason than that. The concavity didn't change. Positive to positive. If it was negative, would it be one? What is the definition of an inflection point? An inflection point is a point where what? Well, I mean, literally, it's not a what? It's not a line, right? So it has a specific spot, right? It's not just an X value, it's an X, Y value. Okay, we all agree with that, right? So our question is this. Good, yeah, you got it? Yeah, good. Okay, this is tough now, right? Let's try to graph it. And again, what did it say? It said that we have that point that we're starting at the origin, 0, 0. I'm going to go up to 9. 1, 2, 3, 4, 5, 6. 10. Okay, now, how did I say I like to start this? I like to start this looking at the maxes and the mins, right? So I have two maxes at 2 and 6. Now this time, what did I do? I staggered them, right? Is that okay? Yeah, as long as they are the locally highest points, right? In other words, this has to be true and this has to be true, right? Okay, good. Now we'll draw those in a minute. Minimums occurring at 4 and 8. These ones I'll put at the same position just because I want to be different. You can do them any way you want. All right, let's see if we can play this game. My first interval of interest is from 0 to 2. 0 to 2, I'm increasing. Not surprising. 0 to 2, I am concave down. Actually, 0 to 3, I'm concave down, but 0 to 2, I'm concave down, right? So when I connect these dots from 0 to 2, we'll put a dot. Is a dot there okay? Can I put it there? Can I? Well, here's the thing, right? Where does this point have to be at 2? Well, it's got to be below the x-axis. We agree with that? Yes? Otherwise, what would I have to do to get there? I'd have to increase, and I know I'm not increasing because it said the what? From 0 to 2, I was decreasing. And I also know it has to be what? It has to be higher than this, right? Why does it have to be higher than this? Because if it was lower, it would have been a local minimum, right? Make sense? Okay. So from here to here, from 0 to 2, I'm going to be concave down, and then from 2 to 3, I'm going to be concave up. So the way I'm going to play it is like this. Concave down. Oh, don't do that, watch. That was too vertical. To concave up. Say again? No. From 0 to, oh wait, hang on a minute. Did I write those backwards again? I didn't put those spots backwards, did I? Oh, up here is 2. Sorry. Now I see why you guys were looking at me weird. Now I see why you guys were looking at me weird. All right. Let's try that again, everybody. Holy cow. From 0 to 2, I am increasing. From 0 to 3, I am concave down. So when I draw this, I got to be concave down. Okay? Going to look something like that. Does that make sense? Okay, I'm sorry that I don't even know what I was talking about right there. Then, from 2 to 3, I have to be concave down. From 3 to 6, I have to be concave up. So I'm concave down until I get to the what? There was a minimum at 4, I think. Okay. So let me make sure I got this. Hang on. Concave down from 2 to 3, concave up from 3 to 4, correct? All right, so we'll put a point here. Down to up. How's that look? All right, so my inflection point was right here. See how I have a changing concavity that starts right there? All right, cool. 4 to 5. Actually, we'll go 4 to 6, I'm increasing. 4 to 6, I'm concave up, correct? Oh, one more thing. Hey, check it out. What is the derivative going to be at 6? It's going to not exist, right? Ooh, you guys are so smart. We're going to put a cusp there. It was concave up the whole way, right? Boom. So when I come out of there, I'm gonna what? I'm gonna come out of there and make that cusp now, right? That was cool. That was cool. Okay, now what? 6 to 8 decrease, that makes sense. 6 to 8 concave up. Actually, 6 to the end of the graph, I'm concave up, right? The end of the graph's going to be at 9. Concave up, going to look like this. Boom. It's all concave up, right? So again, right? It's kind of a tedious process to build this thing because you're kind of looking back and doing a little piece at a time. But again, we now have created a picture that meets all of this criteria, right? And I think that's kind of neat. Yes, sir. What is the derivative at a cusp? It does not exist. And what did we want to have happen here? I have an open point here and an open point here, which means that what? The derivative did not exist at 6. Correct? There you go. Awesome. That's all we're doing. All right.